Hello, this is Professor White. Today we will talk about solving conditional equations, and these are a little bit harder. These are the trigonometric equations. They have sine, cosine, tangents in them, but they're not isolated already. You have to do some tweaking, use some algebra to isolate them, use like quadratic formula, factoring, those kind of things, and also some identities to isolate one trigonometric function. So if everything is given in cosine sine, you want to convert everything to either cosine only or sine only. So we're going to do some exercises and just practice with your book, and I think you're going to learn this fairly fast. So let's get going. So this one is a solved problem, but it's given in this form, solve, and they are asking you to solve something with tangent, and it's conditional, so they are going to restrict it. 4 plus 3 tangent x equals 2 tangent x plus 5. All right? Then you go, okay, well, how do I do this? I move everything to the left, all the tangents, and the numbers on the right. So I just go, okay, well, negative 2 tangent x, negative 2 tangent x, and you have 4 plus tangent x equals 5. Then negative 4, negative 4. Then you have tangent x equals 1. Finally, I isolated that. They need to also give you where they want the answer to be. So they want it to be here. All right. Okay, I can do that. What angle gives me tangent of 1? And that one, for these guys, for the common angles, you just have to do a quick and dirty 30, 45, 60, 90 table for sine and cosine, so that you can actually go calculate cosecant, secant very, very quickly. So this one is 0, 1, 2, 3, 1 over 2, 2 over 2, 3 over 2, and then you put your rads. And the cosine is going to be the opposite. All right, once I have sine, cosine, everything else is easy. What tangent gives me 1? Tangent is, sine over cosine. It is 45 degrees, and they're asking it in degrees. So I go, okay, this is easy. X is 45 degrees. Am I done? No. You have to go and you have to look at it. Where am I? So this is 1, and where's tangent? Positive. Tangent is negative here and positive here. So I got this one. I hit this one, 45 degrees. But even though this one has a reference angle of 45 degrees, it's no longer 45 degrees. And I need to give my answer from the horizontal counterclockwise. You have to go and get this one. So what is the second angle going to be? It's going to be 180 degrees plus 45 degrees for the blue. That one is the blue. So that's 225 degrees. So your answer is going to be 45 degrees and 225 degrees. Let's say they ask the same question this way. Let me get this question. I didn't mean that. Let's go back. I wanted to copy. This time they said, okay, here's another solved problem. But I don't want you to restrict yourself. Just give me all possible answers. All right. So how do I do this thing? Since they are saying real, so that means I need to have this in radian and all possible answers. I go to the previous problem. So you start as the above problem and you get your answer. What was your answer? 45 degrees and 225 degrees. Okay, what is now? I cannot give this in degree because they are saying r. So the answer is going to be then pi over 4. And what was the other one? It was 1, 2, 3, 4, 5 pi over 4. That is good, but that's when it's in one revolution, so that's not good either. So what is my, what's the period of the tangent? The period of the tangent is pi, not 2 pi. So I have to go around it a couple of times. So it's going to be pi over 4 plus k pi, or 5 pi over 4 plus k pi. And I go around it a couple of times. How do I do that? K is maybe -3, -2, -1, 0, 1, 2, and dot, 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 dot. That takes care of all the possible answers. So do understand if they are asking you in degree, in radian, do they want you to be in one revolution or they want you to go around a couple of times? So answer the question. In a multiple choice case, you may have some problems if you answer it wrong, and one of the choices may be the one that you thought is the right answer. You almost got the right answer, but you didn't quite. So always double check. Here's another example. We did the first one. Isolating the tangent was very easy, but it may not be very, very easy if you have some other cases like this. Cosine square x minus 3 cosine square minus 2 equals 0. Well, this one, again, I only have cosine. So it is second degree. This is like a quadratic equation. So go just write down x, the big X, is cosine x. And you're going to simply solve this problem. X squared minus 3x minus 2. All right? Now, that one is not easily factorable. So I'm going to use quadratic formula. And they want you to just limit yourself to this. One revolution. Okay, so for that, I'm going to use the quadratic formula. How did the quadratic formula go? Negative b, which is 3, plus or minus square root of b squared minus 4ac. b squared is 9, minus 4, so that's minus 4ac. So that is 4 times 2 over 2a, which is 1 times 2. So let's clean this up. 3 plus or minus. This can be really ugly numbers. Don't get scared. 2 times 4 is 8. 9 plus 8, 17. Yay! Okay. So you have cosine. Go back now. Cosine of x, either 3 plus that's 17 over 2, or 3 minus that's 17 over 2. So let's see what this one is. The first one is going to be when you plug that in. So let me get my handy dandy calculator. 3 plus that's 17. Okay, that's the top, over 2. Oh, this is 3.6. And this one, when you go 3 minus that's 17 over 2. That one is negative 5, 6. Now you have to think. This one, 3.6, I cannot have a cosine more than 1. That's a no, no, no. All right, well, let's look at this one, negative 5, 6. All right, now I need to take the inverse. What I'm looking for the angle, so cosine inverse of negative 0.56. What does that give me? So I'm going to go and get that from here. Cosine inverse of negative 0.56. That gives me 2.16. Okay? Where is 2.16? Okay, so it's positive, negative. So I got this one. Okay, because this whole thing is pi, 2.16. Yeah, this is the first one. So that is good. But the problem is, I also need this one. Okay, so let's get that one. That one is going to be pi. So if this is 2.16, I need this one. So that means I need to take the pi. I need to get this reference angle. So that's going to be pi minus 2.16, right? And then, so that's my reference angle. And to get this one, I need this. So let's get that. Pi minus 2.16. That is 0.98. Okay, so to get this angle, I need to go pi plus 0.98. That gives me 4.12. All right, so what is my angle? The first one, this guy, and the second one, this guy. So the blue one, 2.16. The red one, 4.12. And since they want me to stay within one revolution, that will be my answer. Okay, now let's do one that has different trigonometric functions in it. For that one, you need to use some identities. Let's say I'm asked to do this. Solve, and I want it in 0 to 2 pi, one revolution. And here's my equation. Cosine x sine x minus cosine x equals 0. Maybe I need, I don't need identities here because I have cosine x repeating. Try factoring in quadratics and those kind of things first. Alright, I was just able to factor. From here, I'm going to get 1. From here, I'm going to get the other one. Cosine x equals 0. That means x is pi over 2. Is that the only one? Pi over 2. And cosine is positive here. I also have the other one, the bottom one, pi over 2 and 3 pi over 2. Ah! For some reason, I closed. So let me see if I'm going to be able to recover that. I hate it when that happens. It just doesn't like me. Did I recover it? Ah, bless you. Thank you. Just not the last one. Alright, I have the quadratic one. Let me save this really quick. Okay. At least we recovered some of it. So I'm going to do the last one more time. Okay, here's the example. Question is solve. Cosine x sine x minus cosine x equals 0. Let me write that down. And then we did factor cosine x out, sine x minus 1. We set cosine x to 0. And then we got x equals pi over 2 or 3 pi over 2. And from here I have sine x minus 1 equals 0. That means sine x equals 1. And that one is simply that one. So sine x equals 1, and that one is going to be x equals pi over 2. And that actually got taken care of here. I have the same answer. So the answer, since the question was limited to 0 to 2 pi, I only have this answer, pi over 2 and 3 pi over 2 from the cosine portion and pi over 2 from the sine portion. So the answer is going to be pi over 2 and 3 pi over 2. Alright, so that is that, and sorry about the little glitch that we had. The computer kind of went crazy at one point.